Hello and welcome to another DazToHue tutorial video. This time we're going to explore how we can apply jiggle physics onto our character in Unreal Engine. There's a couple of different common methods of applying jiggle physics onto characters. We are only going to explore one of them in this video. And I find it helpful to break the problem down into two different parts. One part is how we actually apply the jiggling motion onto a particular bone or bones on our character's skeleton, and we're going to return to that part towards the end of the video. The other part is what is actually driving the deformations of the character's skin, and that's where we're going to start with. So thinking about that second part of how we are actually going to deform our character based on that jiggling motion, there are two common ways of how people actually go about doing that. And I'm excluding things like soft body simulations in Unreal Engine for the purposes of this tutorial because I have tried them, and in my view they're not ready yet for this sort of thing. So the two common methods people often use for actually deforming the character based on jiggle physics motion is to either use weight painting, so actually assigning weights to a particular bone on the skeleton and then using that bone to deform the character. So if I bring up the joint editor, just have a look at this. In this case, it's a Victoria 8.1 character. It's been modified a little. If we take a look at, for example, the character's breasts, Genesis figures do come with a bone onto which the breasts are weighted. And that bone, or those bones, are called the pectoral bones. So in this case, I've got the left pectoral bone selected, and you see it does have controls for up and down motion, as well as left and right motion. And so for breasts in particular, using this skin weighted method would work. However, if you think about other parts of the character where you may want jiggle motion to occur, the Genesis skeletons don't have any bones for those. So if we look at the glutes, for example, there are no glute bones in DazToHue. And likewise, if you wanted some jiggling motion on the stomach area, there are no stomach bones either. Now, it is possible to add new bones onto the skeleton in DazToHue and to paint skin weights onto those bones, and you will find tutorials online for doing that. However, this isn't the method I use because when it comes to, certainly when it comes to the glutes, it's very fiddly to properly paint the skin weights in a way that won't mess up other deformations on the character. So for example, that won't mess up when the character's legs are raised like this. And so for that reason, I have always opted to avoid the whole skin weight painting method altogether. But I just wanted to point out that it is technically possible with the DazToHue workflow to use that method. So rather than relying on having to create new bones in DazToHue and weight paint this skin onto those bones in a way that doesn't mess up other deformations on the character, we're going to forget all of that, and instead we're just going to use morphs to do the actual deformations on our character. Now, the morphs you have access to will very much depend on what content you have purchased from the Daz marketplace or any other Daz related marketplace. You will need morphs that effectively deform the parts of the character that you want to apply jiggle physics to in a way that is somewhat realistic. You can, of course, create your own morphs. You can even get away with just using the built-in deformer nodes in DazToHue to move, for example, the breasts into the correct position. You could hang sculpt morphs in ZBrush or any other DCC. You could certainly do it in Houdini as well. So there's various different ways you can go about creating morphs if you don't have access to any already. For this video, I'm just going to be using whatever I have access to in my Daz content library already. And I think another benefit of using the morph approach rather than just using the bones to drive the character's deformation is that you can get a more realistic result. If you are just using the bones to drive the deformation on the character, you will just be getting linear motion, so up, down, left and right, which isn't anatomically correct for a lot of areas. Things like breasts, they don't just move up and down linearly. It's all to do, I guess, with physics and soft body physics in particular and things like that. And you can sort of fake a lot of that with just really well crafted morph targets. And you're not going to get that same result with just using linear skin weights on on the character. Okay, so to get started, I am just going to load the standard G8.1 ROM onto this character. I'm not going to worry about the face controls for this tutorial. I'm just going to hold down Control, double click our 8.1 ROM, turn off limits and accept, say yes to extend the timeline. So the standard 8.1 ROM without face controls is a total of 404 frames. So we need to add a few frames at the end of this timeline to set up our jiggle morphs. So I'm going to add another 32 frames to our timeline down here for our physics morphs. So that instead of the total being 405, it will be 437. As you can see now at the end of the timeline, we have those additional frames. So the last of our ROM animation poses is 404. So I'm going to go to 405, frame 405, and now I'm going to zero out the pose again. So I'm going to go up to Edit, Figure, Zero, Zero Figure Pose. So now we are starting on frame 405. We have the zeroed out figure. We still have all of our standard ROM before that. Now we can start on adding frames for each of our physics morphs that we want to add. So for this tutorial, I'm going to be adding 8 frames for each of the characters' breasts and glutes, hence a total of 32 new frames. Okay, so at this point we can start adding the morphs for our jiggle physics. So I'm going to be starting on frame 405, which is the frame after our ROM ends, and we have zeroed out frame 405, so we're now back into the character's default rest position. Now I'm going to start with the breast morphs. So I'm going to search for breast and find some suitable morph controls that we can use. So I have these controls, which have a separate left and right morph for in and out and up and down motion. You will want to have separate left and right controls. Now, what you have access to will depend, as I said, on what you have installed, what you've purchased from the marketplace. Or as I said at the start of this video, you can relatively easily create your own morphs and either bring them into Daz or apply them in Houdini or various other ways. So to get started, I'm simply going to take one of these controls. So we'll start with the left breast, and I'm going to move it all the way to the right, which is moving it out. Then I need to go back to the previous frame and zero it out, because we always want each frame on our range of motion timeline to be a distinct pose. You don't want them overlapping. And the way Daz works with keyframing is a little tedious, I find. You will often have to go back and zero out the frame before. So you can see on frame 404, we have the last frame of our range of motion. And then on frame 405, the head has been zeroed out again and the left breast has been moved out. Next, I'm going to go ahead one more frame, and this time I'm going to move it up. So in this pose, we have the breast going diagonally up and up and out. And again, I need to go back to the previous frame, make sure that is zeroed out, which it is. The next frame will be just up. So I'm going to zero out the left-right motion. I'm going to go back to the previous frame and just make sure that stays at 100. So if we scrub through now, we have the breast going out, diagonally out and up, just up. Now we are going to bring it in. Now we're going to zero out the up and down motion. So it is now just in. And the previous frame, it was both in and up. And the next frame, it's going to be down. So it's going to be in and down. On the next frame, it is just going to be down. So we're going to zero out the left and right motion. And remember, we need to go back and just make sure that that previous frame is 100% in. Next, we are going to bring it back out. So this one is down and out. So if we just go back through those, we have the left breast pointing out, pointing up and out, pointing up, pointing in and up, pointing in and down, pointing down and pointing out and down. And theoretically, the next frame would just be out, but that is the frame that we started with, so we don't need to add it again. Basically, if you think of it as cardinal points on a compass, north, south, east, west, plus we have the diagonals, so it's 8 poses per breast. And so on the next frame, we are removing all of the changes to the left breast, so we're basically zeroing it out again. I'm just going to make sure we have keyframes for there. We'll go to the next frame and set these back to 0. And again, just make sure we are getting distinct linear keyframes on each of these frames. You don't want any interpolation between them. Okay, so now we just need to repeat the process for the right breast. It will make your life easier when it comes to the Houdini part of this workflow to mirror the exact same poses. So we started with the left breast being out, and then we went up and basically did it in an anti-clockwise. We want to do the same for the right breast. It'll just allow us to easily mirror things in Houdini and not have to do as much work. So I'm just going to do that. So I'll start with the right breast out this time. Again, I'll go to the previous frame, make sure it's starting on 0. Now it's going up. Another thing that you might find helpful is you can just zoom in on the timeline to this section. Makes it a little easier to scrub through. Okay, so we've finished the left and right breasts now. So if we just scrub back through the morphs we've just added, we have the left breast going out, up and out, up. You can actually see we're getting some drifting, some interpolation happening for the right breast when it shouldn't. The way I typically fix that is if you just click in the tree over here and hit Control A to select everything. Right click, select all items keyed, and you wait for it to select all of the keyframes like it has there. Then I come over to here and make sure the frame interpolation is set to linear. So just to recap, we have the left breast pointing out, up and out, up and in, down and in, down and out. And then we have the same for the right breast. So on the next frame, we're going to zero everything out again. So I could just set these to 0, or I can come up and select figure 0, 0 figure pose. So that's it for the breasts. Now, as I said, we have 8 cardinal directions for each breast. And it's exactly the same process for the glutes, which I'm going to fast forward through so you don't have to watch that again, but it is exactly the same process. If I search for glute, find some suitable morphs. I have these available, so the left and right, I do have some ones we can use. There is a move side and side for the left. A little hard to see that clothing for turn on wire texture, maybe that'll help. So we do have side motion. Looks like there's 2 up and down motions. Not sure what the difference is. Slightly different variations. So again, I would do the 8 cardinal points for the left and right glutes. So like I said, I'll fast forward through this so you don't have to sit through it. Okay, so we finished doing the morphs for our glutes, exactly the same as we did for the breasts. It is a little bit of a tedious process. You do get faster at it the more you do it, and you can always save, remember, so you can always save this new ROM as a preset to your library so you don't have to do it again. You might be wondering why I don't include a ROM with these already set up. The reason for that is that I can't be sure what morphs everyone's going to have access to. I don't know what suitable morphs come standard with DAZ figures or what came from content I had purchased from the marketplace, for example. The only way I could be sure everyone had access to the same sets of morphs would be if I were to create those morphs myself and bundle them with DazToHue, which I might do one of these days, but haven't at the moment. That is why DazToHue doesn't come with a range of motion already set up for these sorts of Jiggle morphs. Alright, so with that done, I am now going to export this character just as we do with the DazToHue workflow as both an FBX animation and an Alembic cache. I'm going to send to Maya as an animation. Everything on my character is subdivision level 1. I'm going to export the FBX. And I'm also going to export it as an Alembic cache. Not going to go over details because this is covered in other tutorials. So once that's finished exporting, we'll come back to the video and head over to Houdini. So here we are inside of Houdini, and I've already gone ahead and brought in the character we just exported out of DazStudio, and I've prepared it up until the pose asset node, which is where we're going to start the second part of this tutorial. But I'll just quickly recap a couple of important things to know. So on the skeleton node, in this case I'm targeting the UE5 mannequin skeleton. I've added the IK bones, but importantly for this tutorial, I've also added the breast and glute physics bones, which we will be using, and I've actually also added the stomach physics bone, which we won't be using in this tutorial, but added it anyway. I've done a quick occlusion cull of the character underneath the clothing just to help minimize poke through. I've set up my materials in the same way I always do, and now we are up to the pose asset node, which is where we're going to be working on most. So if you recall, when we were in DazStudio, I used the G8.1 example ROM without the faceboard. So I'm going to start by loading that preset onto the pose asset node. And that will have defined all of the poses up until frame 404, which is where our example ROM ended. And you recall we added 32 frames after that frame, which has our breast and glute physics morphs in them, and you can see them there. Before we actually get started mapping our physics poses onto the pose asset node, just want to quickly talk about why we are doing what we're about to do. The way we are going to actually drive these morphs inside of Unreal Engine is we're going to use something called a pose driver node in the animation blueprint. Now the pose driver node is fairly complicated to understand, and there's not really any good documentation out for it. But what it basically does is it uses what's called a radial basis function, and what that allows us to do is control the weight of various morphs that are being applied based on the distance between the bone and a target position. That'll become more obvious in a minute, but the point I wanted to make is that it's quite tedious to set those pose drivers up in Unreal Engine, but luckily DazToHue will make that a lot easier for us. But the trade-off is we have to do some more setup on the pose asset node. But then it means we have to do far less setup inside of Unreal Engine on the pose drivers themselves, and it's a much better way of working, in my opinion. Hopefully it'll make more sense as we go. So what I'm going to do is head over to the Physics tab on the pose asset node, and also under Visualize I'm going to change it to Physics Helpers, and then under this Helpers section I'm going to tick this Show Helpers button. Next, we're going to create a new physics group by clicking this plus button here. So we're going to follow the same order that we set our physics poses up in DazStudio. So we're going to start with the left breast. And if you recall, that started on frame 405. So we have our left breast out pose. The first thing I need to do under this physics group is tell it which bone is going to be driving these morphs. In this case, it's going to be our breast underscore L bone. Remember, that's coming from the skeleton node when we added the breast physics bones. You'll see now that we get a circle in the viewport here. And this is visualizing the radius that will ultimately be assigned to our pose driver node in Unreal Engine. And you can change the size of it, but we'll leave the offset distance at 5 for now, and we can come back and tweak that at the end. For now, let's just start to add our individual poses for this left breast. So under the physics group here, I'm going to add a new one. The frame will be the frame we're on, which is 405 down here. It's the first of our left breast physics poses. I'm going to give it a name, so I'll call it breast out in this case, because it's the pose where the left breast is pointing outwards. We don't need to put a suffix or prefix or anything. That's coming from up here, so we're now working on the left side of the skeleton. Now what we want to do, this diamond shape in the center here represents the target location for, in this case, our left breast out morph. What we want to do is get it onto the outside of this circle. So using Houdini's world space coordinates, where Y is up and X is side to side, I need to move it out. So if I come to the X value of our offset here, and I'm going to move it out to -5, which puts it right on the radius of this circle. Actually determining the best offset distance is a bit of trial and error. And these values are easier to tweak globally in Unreal Engine. So really the time saver here is these offsets. These are a pain to set up in Unreal Engine. So by doing it here, it means that we won't have to do it in Unreal Engine. This offset distance radius is what it effectively is. It denotes, I guess, the maximum that our bone will move once its jiggle physics has been applied. And it's based off its default rest position. So if I come back to a frame where the left breast hasn't moved at all, it's right in the center. And if I go to our 405 frame where it's out to the maximum it can go, this bone, that's kind of where our offset distance should be. And we also want to check the diagonals. So if we look at the up and out, it's about right. I've found 5 to be a good value for this field for Genesis figures in particular. So we're going to leave it at 5, but just wanted to be aware of that if you're working with different skeletons, you might want to adjust the offset distance. So we'll come back to defining our individual morphs. So we're going to add another one, which will be frame 406. This one is going to be breast out up. And again, we want to get it onto this outside radius in a diagonal up into the up and out direction. So we'll start by moving it out roughly so it's in line with that bone. And then we'll go the same for vertically. And from experience, with a radius of with an offset distance of 5, I found that values of 3.5 will work quite well. It'll get it right on that outside radius. And we do want some overlapping between our individual morph targets here as well. So we're just going to carry on now, which will be 407. You don't have to scrub the timeline, but it helps, I think, if you're new to this. And this one is going to be straight up, so it's just going to be a value of 5 in the y-axis. Our next one was up and in. Oh, sorry, I need to give this one a name as well, so that 407 is the left breast up. 408 is going to be in and up. And its values are going to be 3.5. We'll bring it in. And 3.5. We'll bring it up. So we now have it sitting on this part of this radius. I'm going to keep going. Next one will be 409. That is just going to be the breast in. And it's just going to have a value of 5. Next one will be 410. And it's going to be in and down. It's going to be 3.5 on the X, and it's going to be negative 3.5 on the, oops, negative 3.5 on the Y. Next one's going to be 411. It's just going to be called breast down, and it's going to be negative 5 on the Y. And our last one for the left breast will be 412. It's going to be out and down. It's going to be minus 3.5 on the Y, minus 3.5 on the X. So you can now see we have our 8 overlapping morph target locations for the left breast. And what DazToHue is going to do is export a couple of files that'll just make setting all this up in Unreal Engine a whole lot easier. Appreciate it is a little fiddly to set up initially, but just as you could have done in DazStudio, you could save the ROM animation with our jiggle poses at the end of it as a preset in DazStudio. Once we've finished mapping all of our physics poses onto this pose asset node in Houdini, we can also save it as a preset. So it's something you only have to do once, and then you can reuse across multiple characters quite easily. So we now have the left breast done. Now, if you recall at the start of this video, when we were setting up the pose assets, I mentioned that it was good to do them in a way that they were mirrored from left to right. If you've done that correctly, then we should just be able to come up to the top of this left breast section and click this mirror down button. The axis we want to mirror on in this case is the x-axis, which is our side-to-side axis. So we want to mirror it from this side to that side. Axis is going to be x. I'm going to hit accept on that. Now you can see it's automatically defined the same setup for our right breast. So if I scroll down, you'll see we now have this new physics group with the driver bone being the right breastbone and the same setup that we had for the left. So that's all we need to do for the breasts. Now if we move on to the glutes, we're going to do the same sort of thing. We're going to set up the left and then mirror to the right. If you scroll down to the end, you can insert new physics group after this point. The driver bone for this one is going to be our glute left, and it's exactly the same as we did before. So we're going to be starting at frame 421, which will be the first frame of our left glute. A little harder to see with the glute. I might turn on wireframing. So 420 is the rest position. 421 is the glute going in. So I'm going to call it glute in. And I need again to move this target to the inside of this radius. It gets a little tricky because we're working in reverse now, working on the back of the character. But it'll be a value in the X offset here. And it'll be a positive value of 5 to get it onto that radius. The frame for this one will be 421. And we're going to move on to the next one, which is in and up. So we'll call it glute in up. Frame will be 422. And again, the offsets for diagonals, given our offset distance, will be values of 3.5. So we're going to go 3.5 in the x-axis, and the y will be positive 3.5. I'll bring it up to the outer circle. So that's it. We've finished setting up the pose targets for the left glute bone. And we can do the same thing as we did before. We can mirror it down. It will also be on the x-axis. You can hit accept. You can see now it's copied them over to a new physics group for the right glute bone. So we now have all of our pose targets set up. Now, like I said, this is all to save time in Unreal Engine. Really, the only mandatory things you need is a frame number and a name. You can leave all of these and do all that work in Unreal Engine if you want, but I've found it's a lot easier to do it this way. And I can also, as I said, save a preset now, which means I won't have to do it again for theoretically any other Genesis 8.1 characters with this preset. So I am noticing this little exclamation mark here. That's an indication that we might have made a mistake somewhere along the way. If I hover over the node and click this exclamation mark to the left, you can see a warning at the top saying duplicate pose asset name found. And it's suggesting that I might have used the glute out, down, left, and right twice. So I'm just going to have a check of that to see if I've made a mistake somewhere. And I have. I've used glute out and down twice, so one of these is wrong. So I'm going to start by going to frame 426. And 426 should indeed be out and down. 428 should be in and down. There. And so if we look at the right now, I've done it again because we just mirrored them down. So 434, which is this one, should be out and down. So that's correct. 436, which is this one, should be in and down. And if you click off the pose asset node, we can see the exclamation mark's gone away, which denotes that we've solved all the problems we had. So we are now ready to export out of Houdini. So if we come to the export node, we're going to change a couple of settings that will just make, as I said, setting up things in Unreal Engine a whole lot easier. First thing we're going to do is come to this pose asset section, and I'm going to tick export physics pose asset animation. We're going to want that. I'm also going to export pose driver code because we're certainly going to want that. As I say, this will make setting things up in Unreal Engine a whole lot easier. And we're also going to export pose asset names. So they're the only things we need to change. I've already told it where I want to export to. Just going to save it. And now I'm going to export with selected options. Okay, so that's now finished exporting. So we take a look at the export directory for this character. We can see we have some other files that we probably haven't seen before in DazToHue tutorials. These are getting into the more advanced workflow side of things, but all of these sorts of assets were used to create all of the Unreal Engine content that comes with DazToHue. So as well as our standard character FBX file and our textures folder, we have our pose asset, physics pose asset animation, which we're going to look at in a little bit. We have some text files which contain the names of, in this case, the important one is our physics pose asset name. So if you open that, these are all of the physics poses that we defined on the pose asset node in Houdini. They have been given their global prefix and their suffix left and right. We're going to want to be able to copy and paste those into Unreal Engine in a little bit. And we also have this pose drivers folder. So if we open that up, go into the physics folder, you'll see we have a text file for each of our physics groups. So one for the left breast, one for the right, one for the left and right glutes as well. If we open one of those up, we'll get this crazy looking code. And this is basically the definition for a pose driver in Unreal Engine. So what we'll be able to do is just copy and paste this into our animation blueprint. That will generate a pose driver node with all of these morph targets already set up. And this is the thing I was always trying to avoid by doing it this way, defining all of these in Unreal Engine, having to determine what these values are and copy and paste them into a pose driver is so tedious. So by doing it this way, we don't have to do any of that. It's much quicker to set up. All right, so let's head over to Unreal Engine and take a look at how we actually start to use these physics morphs. So here we are inside of Unreal Engine with what is basically the default third-person level scene. So if we just hit play, we can see the mannequin skeleton running around. The first thing we want to do is import our character and replace that mannequin figure with our own. Now I covered this in a previous tutorial, so I'm going to go through this quickly. I will leave a link to that tutorial in the description, assuming I remember. But to get started, let's import our character. Because we are targeting the mannequin skeleton, we want to make sure the skeleton is this SK mannequin. We want to make sure use T0 as ref pose, and we certainly want to make sure we're importing morph targets. I'll just quickly scroll through the rest of the options, but as I say, these are covered in a previous tutorial. So I'm just going to hit import all. Now I have already set up materials for this character, so they should be auto-discovered when the character is imported. Okay, once our character has been imported, I'm just going to open up the skeletal mesh and just change a few things on the skeleton, retargeting options to make it work with the mannequin skeleton, like that. I can now save that. If I come to our third person level blueprint and open that up, replace the mesh with our character. While I'm here, I'm just going to bring the camera forward a little. Now if we hit play, you should see our character running around. At this point we don't have any jiggle physics going on. We also don't have any joint corrective morphs. So let's sort that out next. I'm going to go to the DazToHue folder, under the mannequin folder. In this case it's the Genesis 8.1 figure. Going to select all of the pose assets, right click and replace skeleton. And we're going to replace it with the SK mannequin skeleton. Now do something similar for this DTH Genesis 8.1 UE5 animation blueprint. Right click that, assign skeleton. Select the same SK mannequin skeleton and accept. Once that's done, I'm going to go back to our character skeletal mesh, open that up again. Under asset details, search for post and assign that animation blueprint. And it's inside that blueprint that we're going to be setting up our jiggle physics. But now save the skeletal mesh again, and close that now and that. If we hit play, we're now running around. We have at this point joint corrective morphs working. Still no physics motion. So this will be our starting point. Now you recall at the start of this video I mentioned that there are two common ways of applying the actual jiggle motion to bones in Unreal Engine. The first method is to use a physics asset, and that does come with some benefits but also some downsides. The key benefit for using a physics asset is that it can respond to external collisions from the environment. So if it is important for your project that jiggle physics responds to external collisions, then you're going to want to use a physics asset. The other, perhaps lesser benefit of using a physics asset is it does give you slightly more controls or properties for the actual physics motion than the method I'm about to show you. The downside of using physics assets is that they are a little more complicated to set up, quite tedious in some scenarios. They are more difficult to share between characters unless those characters happen to have the exact same body proportions. And they're also more complicated to dynamically control the physics properties at runtime. So if your project has something like a character creator in it where the users can control the shape and size of the body and various properties of the body, then you may well also want to be able to control the jiggle physics properties dynamically. And as I say, that's more difficult to do with a physics asset than with the method I'm about to show you. As a quick example of what I'm talking about, this video from my YouTube channel that I put up ages ago showing a character morphing between a heavy set character and a slim character. And you can see as the character gets slimmer, there's less jiggle physics being applied to the breasts. As the character gets heavier again, there is more jiggle physics being applied. So that's an example of what I'm talking about in terms of being able to dynamically control the jiggle physics at runtime. As I said though, we won't be using a physics asset for this tutorial. Instead, we're going to look at an easier way of applying jiggle physics. And that is all done inside of an animation blueprint. Now in this case, I'm going to be applying the jiggle motion as a post process. So I'm going to be doing it inside of the ABP DTH Genesis 8.1 UE5 animation blueprint, which we have added as the post process blueprint to this character. Inside this blueprint, we will see our joint corrective morphs and also the facial morphs and facial solver control rig. So we're going to be working after the joint corrective morphs are applied, so in this section here. Now, in order to see some jiggling on our character, we're going to want an animation. So over here, I'm just going to search for walk to start with, and I'm going to select this MF walk forward. Drag that out. I'm going to set it to loop, and I'm going to replace our input pose with this animation. Now, if I compile, we'll see our character walking. Still at this point with no jiggle physics happening. So next thing we're going to do is drop down a spring controller. So if I right click, type spring. I'm going to select spring controller. I'm actually going to copy and paste it. We'll have two of them. We'll start with the left and right breast. I'm going to connect those up to our animation graph. When I connect that up, it'll do a local to component transform automatically for us. When I connect it back out again, it will convert it back. So let's take a look at the properties on these spring controllers. The first thing we need to do is give them a bone to effect. So I'm going to select the first one, type in breast, and we're going to select the left breast. The second one, I'm going to select the right breast. And then we're going to compile. You can see now we are getting some motion on those breastbones. So now I'm going to select both of these spring controllers so I can adjust the remaining properties at the same time. There's really only two properties we have to work with. One is spring stiffness and the other is spring damping. Really, it's just a matter of playing with these two values to get the effect you're after. But before we start changing these parameters, let's actually hook up our pose drivers so we can actually see the morphs being driven. So for now, I'm going to close that animation blueprint. And I'm going to go back to our characters folder, and now I'm going to import this physics pose asset animation that we exported out of Houdini. On the import options, I'm going to deselect import mesh because we don't need the mesh, we just need the animation. For the skeleton, it will also be SK mannequin skeleton. The rest we can leave as is, so I'm just going to import all. Now if I open that animation up, you can see inside it we have animated curves for each of our physics morphs that we set up in Houdini. What we basically need to do is create a pose asset that contains all of these poses for our Jiggle physics. And the easiest way to do that is with this animation, because once we have this animation, we can simply come up to create asset, go to create pose asset and select current animation. We need to tell it where we want to put it. So I'm going to put it inside our characters folder. We'll give it a name. I'll call it PAS for pose asset. I'll call it Victoria 81 PHY for physics poses. You can come up with your own naming convention. Now I'm going to hit OK. Then I'm going to save that. Now I'm going to go back to our characters export folder, and you recall we had these text files. So you're going to open the physics pose asset names text file. I'm going to Control A to select everything, Control C to copy. And okay, come back to our pose asset, right click at the top here where it says pose name and paste pose name. Then I'm going to save. So now we have this pose asset that's being created, and that's what we need to feed into the pose driver nodes in our animation blueprint. We no longer need this animation sequence, so we can get rid of that. Okay, so now we're going to go back to our animation blueprint where we left off. We still have our spring controllers and some jiggle motion happening on our breastbones. The next thing we're going to do is go back to our characters export folder. We'll go into the pose drivers folder and into the physics folder there. I'm going to open this breast left text file, and again I'm going to Control A to copy all. Inside our animation blueprint, I'm going to hit Control V to paste. And you'll see that has now created a pose driver for us with all of the morph targets we set up in Houdini. And more importantly, all of these transforms, these positions for those targets. As I said when we were working in Houdini, it's a pain to do all this inside of Unreal Engine. I find it much easier to do in Houdini, although it is possible to technically do it all inside of Unreal Engine. So we now have a pose driver for our left breast. Let's also grab the right breast while we're here. Paste that in. So we now have both pose drivers. These pose drivers work in local space, so it needs to be applied after this transform back to local. So I'm going to connect them up here. Join them up. Then I'm going to select both of them, and we need to tell it which pose asset to use, and it will be the one we just created, which I called PAS Victoria 81 Physics. So now I'm going to compile. So if I select one of these pose drivers, we'll see now we are getting the morphs driven, and they're being driven by how close the tip of this breastbone is getting to each of our morph targets. Now there's a bunch of different options on these pose driver nodes. The most common ones you're going to want to play with are under these RBF params for section. RBF is radial basis function, which is effectively how the maths of all this works. So it will be up to you again to play around with these to get the best result. You'll see the radius has a value of 5, and that matches the value of 5 we had in Houdini when we were setting up these. You can change it here. You can also change the solver type from additive to interpolative. And I don't want to go into the differences between them. I don't fully understand it myself, and there's really no documentation around them. I'm going to leave it as additive for now. The other thing you might want to play around with is the distance method. Each of these will have some impact on the weighting that's applied to each of the morphs as that tip of that bone moves into that morph target space. Just go back to our spring controllers. So after a bit of playing around with the parameters on these spring controllers, these are the values I've ended up with that I'm relatively happy with. What I actually did was turn on limit displacement, and I set the max displacement to 5, which again matches the value we had set as the offset distance in Houdini. Spring stiffness I upped right up to 350. Spring damping I reduced to 6. So now let's take a look at what this looks like inside of our third person level. To do that, we need to disconnect the animation and reconnect our input pose, then compile and save. Now if I hit play, we can see we are getting some jiggling on our character. And so really it's just a matter of tweaking both the parameters on the spring controller and the parameters on the pose drivers to get the look you're after. Just for completeness sake, let's connect up our glute jiggle morphs as well. So I'm going to make some space here. Going to copy and paste our spring controllers. Connect those up. The first one will have a spring bone of glute L. Second one will be glute R. And we also need to bring in the pose drivers for our glutes. So if we go back to our pose driver physics folder, open up glute left, copy and paste that into the animation blueprint. Do the same for glute right. Connect those up. I'll just change the values just so they match our breasts for now. You probably will want to tweak the values for the glutes and the breasts separately. They'll have different physics behavior on them. But for now, let's just hit play and see what we get. Whoops, sorry, I need to go back and disconnect our animation, reconnect our input pose. Now if I hit play, you can see we are getting some jiggling on the glutes. Probably more than you would want if you're going for anything resembling reality, but for this tutorial, I'm just going to leave it at that. So that is basically it for one way we can go about getting jiggle physics onto our characters using the DazToHue workflow. As I said right at the start of this video, DazToHue supports all of the different methods, either with physics assets or with skin weights painted onto bones, or with the morphs that we've used here, as well as the spring controllers. So it's flexible in how you can set this up. Really depends on what you need for your project and sort of what level of realism you're going for, I suppose, as well. What I like about the morph-driven approach is that I think it's a lot more flexible and easier to set up. You could basically repeat the same process for wherever you want jiggling on the character. For example, the stomach or the thighs. All you really need is the morphs to get started with it. And like I said, they are relatively easy to create. So I'm going to leave this video here. I hope that was helpful, and I'll see you in the next one. Bye.